We've talked about how to construct the hypotheses for a test. Now we need to talk about how we conclude a test. And then we'll circle back to the middle part where we actually conduct the calculations that let us reach these conclusions. But for now, we want to focus on how we decide to reject or fail to reject the null hypothesis, which will inform the conclusion of our test. Hypothesis tests begin by translating a claim into our two hypotheses. At the start of every test, we assume that the null hypothesis, h sub 0, is true, regardless of whatever else we see or believe. We start with that assumption. Then we select a significance level, or one is given to us, but in the real world we would select a significance level, alpha. Again, keep in mind common values for the significance level would be 0.01, 0.05, or 0.1, depending on the severity of the situation. Then a test would be conducted, resulting in what's referred to as a p-value, which we will compare to our significance level of alpha. The p-value is a probability, meaning it will be between 0 and 1, and it's specifically the probability that our sample results were due to chance. More specifically, if our p-value is greater than alpha, the significance level, then our results are likely due to chance. This would be something similar to an example of flipping a fair coin 10 times and only getting tails once. That wouldn't rock the fabric of probability and statistics. We would just chalk it up as the variability of samples. That one time you only got tails once, but if you repeat the experiment, you would likely get different results. It doesn't mean that the true probability of getting tails is something different than 50%. If our p-value is less than or equal to alpha, then our results are unlikely to be due to chance. If we use that coin flipping example again, that would be a scenario where, let's say now we flip a coin 1,000 times and we only get tails popping up maybe 10 or 20 times, a small number, something much less than half. Well, now we might start to suspect that this isn't actually a fair coin. Something else is going on because the probability we thought was 50-50, but we're not getting that, even with larger samples and more evidence. If our sample results are unlikely to be due to chance, then the null hypothesis is unlikely to be true. Keep in mind we started off with the assumption that it is, and then potentially we're presenting enough evidence to suggest that it's not. That is, a small p-value discredits the null hypothesis, which we were assuming was true. So if our p-value is greater than alpha, meaning our probability is large, then we fail to reject the null hypothesis. But if our p-value is small, and by small we specifically mean less than or equal to the value for alpha that was chosen, then we reject the null hypothesis. Keep in mind that throughout this process, we never prove anything. We avoid using that word. What we do is reach a conclusion based off the data available. It's always possible that more data or data from a different sample could yield a different conclusion. If we fail to reject the null hypothesis, then we maintain the assumption in the null hypothesis. We aren't proving it to be true. We just don't have enough evidence to reject it, to discredit it, so we continue to maintain that assumption. If we reject the null hypothesis, then we're saying there is sufficient evidence to discredit the assumption in the null hypothesis. Again, it's a lot of somewhat complicated, wordy language to get at the idea that we're not proving anything. We're just reaching a conclusion based off the data that we have. The data makes the null hypothesis unlikely to be true, or the sample evidence that we have doesn't really do enough to refute it.